Okay guys, so today we're going to talk about the do now from today, and I'll show you guys that we're going to add two vectors together and find the resultant. Now, when we usually add two vectors together, let's say right now they're tail to tail, you'd add them together head to tail, and then what you would do is you would come in, oh no, don't do that. You would come in and you would end up doing something like this, adding them head to get tail, and you'd find the green arrow, which is the resultant. But that's not what we're going to do today. Today we're going to actually have to mathematically find them. And we've kind of went over the steps, all the steps needed to do this. You just need to apply a lot of things you know. So the first thing is, guys, vectors are much easier when we deal with them by their points of their heads. So if you knew this, oh crap. If you knew that this was x, y, and this was xy, it's like some points, you could just simply add the coordinates together and you would find the resultant. So the main thing is taking this annoying representation of these vectors and converting it into the points, which are the ends at the very head of the vector, and then just adding those points together, guys, and then you'll find another point, which is probably somewhere over here. Actually, no, we know it's going to be somewhere up here. It's going to be fantastic. Alright, so to start off, guys, we have a simple formula. It's on your reference table. It's in the book. I'm going to use this one, instead of what Mr. Lee taught you. It's going to be ax equals a cos theta, and ay equals a sine theta. Okay, so we've got these two formulas. Now all we have to do is apply them. Now remember, guys, each vector is going to have 2 points. So each of these formulas need to be applied to each vector. It's going to be a little annoying how it looks because I named a vector A and the formula has A in it. But this A does not correspond to the A vector. It corresponds actually to any vector. So once again, guys, take a look at your reference table, read the book. It's going to help you out a lot. I'm going to make this side of my paper for A. I'm going to make this side of my paper for B. I'm going to say ax equals a cos theta, and I'm going to say bx equals b cos theta. And these are different thetas, so maybe if I wanted to be even more specific, I call it theta A, and this is like theta B. I don't want you guys to think that they're the same theta. And then I have a y equals a sine theta A, and then we have by equals b sine theta b. And what I mean by these thetas, this is the theta A, and this right here is theta b. And these A's and B's, guys, they just represent the length of your vectors, guys. Don't get too confused. They're just the length of the vector. So this B is the length of vector B, and A is the length of vector A. Nothing difficult. So let's just plug it in. We know these lengths. I just go down and you just go back up. A is 20 and B is 17. So I'm going to go 20 newtons, 20 newtons, 17 newtons. Up, don't move it. That's going to be a little annoying to do, guys. I apologize for this. That's the only problem with this program, is that it's a little bit hard to go back once you've drawn something. 17 newtons, 17 newtons. And then we're going to go cos 180, sine 180, cos 32, sine. Oh, come on. Cos 32, sine 32. And what we'll find is this, guys. We should be able to get our formulas together. Now just plug these in your calculator. Should not be too difficult, and you'll quickly see that this one is going to be a 0 newtons. This one is negative 17 newtons. This one is 16.961 newtons. And this one is going to be, 1 second, 10. What did I mix these up? I think I did. Did I? Yes, I did. This one is 16.961 newtons, and this one's going to be, sorry, it's running out of space. 10 point, oh, don't do that. What's going on? I don't know. 10.598 newtons. Okay, so we've got all that squeezed in. Let's scroll down to give ourselves some more space. So what we get, guys, we're just going to add up our x's. So I'm going to take ax plus bx, comma, ay plus by. And in fact, guys, I'll just end up, once I do this, with the coordinate that represents the end of my resultant. Okay? So I'm going to go 16.961 minus 17, which is going to give me a negative 0.039 newtons. And then I'm going to go the other one. Well, the other one's quite easy, actually. There's nothing with it, so it's just going to be a positive 10.5, 10.5, where am I at again? 98 newtons. Okay, so I've got my points, guys, and this is the point that represents the end of a vector. Now, I'm just going to draw this very vaguely. It's going to be a little bit bigger than what it actually is. I'm just getting another document up here, blank document, so I can do some more work. So I have my 2 points. My 2 points, and I'm just going to go to the very top again. And I'll make my 2 points. I have 0.039 newtons, comma 10.598 newtons, and the first one's negative. And this is negative. And this is my point that represents the end of my resultant. So I can just say this. My resultant's at. Okay, but this is not what it asks. The question actually asks, if we look at it very carefully, it says, find the magnitude. And this is giving me my points at the end. So I need to find the magnitude or the length. Now, how do I find the length? Well, you've got this. You've got, here's your origin. Here's this point up here. And I'm being a little vague about it. Now, you should realize, guys, that we can take this right here, and we can take, stop. This right here, and if I define these a little better, this is my y coordinate and this is my x coordinate. If I find those, well, what I can do with that is I can go up. I can do this. I can find the resultant because this is a right triangle. Okay, so easy peasy. How do you find the length of a resultant? A length of the hypotenuse of a right triangle. Pythagorean theorem, guys. So remember, your x is this value, your y is this value. So just plug it in. So you're going to take negative 0.039 squared plus 10.598 squared. I'm doing the Pythagorean theorem and taking the square root. And you should actually end up getting basically this number again. Do the Pythagorean theorem with these 2 points. Do it. Do it now. Some of you guys really need to not just sit there and watch Mr. Shaw do work in class. So you should be getting the answer. I'm just going to write this up again. Equals c squared. And this is in fact going to give us, once we square these and take the square root, it's going to give us what our resultant, the length of our resultant, and you should get a value equal to 10.598. Wow, didn't really change much. No, it did not. But once again, some people really wanted to round this. I don't want to see you guys rounding values down to 0 because you're basically saying they don't exist. What if I rounded you down to 0? I'm just kidding. So this is the length of our resultant. Now, the one thing to realize, guys, remember when we go back to the very beginning, these were two forces, two concurrent forces. And when we find the resolution or resultant of two concurrent forces, this value right here, very important to realize, is our F net. Wow, that turned out actually looking pretty cool. Alright, so we've got our F net, or our resolution of two forces. Now remember guys, for part 2, we're going to go to back to the question again. Part 2, the object has a mass of 6 kg. Find the magnitude of its acceleration. Well, this will be pretty easy, guys. Remember, F net equals ma, and we know, did I not say this? Yes, it has a mass of 6 kg. Mass equals 6 kg. We're just simply going to plug that in. You're going to get 10.598 newtons equals 6 kg. Sorry, didn't need to put it equals there, times acceleration. In parentheses. Okay, just divide both sides by 6. Divide it by 6, and you should get an acceleration value. Acceleration equals meters per second squared. You should be doing this on your calculator right now. 10.598 divided by 6, and you should get 1.766. Okay, and that's your value for your acceleration, and I'm done. Alright guys,